Right, welcome back to recap. So here, we're going to talk about the difference quotient today. So there's a little intro before we're actually going to get to it. Okay, so first thing I want to remind us, it's this thing. You guys remember this formula? This is your slope, right? Now, what we're going to do with slope is we're going to kind of constrain the idea of slope to lines. And so we still want the idea of like how things increase, but maybe something that's not a line, something that's just a squiggle. So if I want to figure out like what's the slope between these 2 points, right? We're not going to call it a slope. Technically, this is called a secant. If I just pick one of these points here, we just get one, I just touch it at one spot, this would be called a tangent. Okay. We're going to talk about secant more or less. And the idea, like how would I do this? Okay. So we draw a little thing here, and what I want to do is look at the piece here. So let's go ahead, and if I have my this is the value of right x equals a. This is the value x equals b. And I look at the y value here, right? What is this y value? Well, that's going to be f a, right? A, right? X equals a. The y value, this is y. This is x1. And then we have our here, right? What's the height here? This is fb. It's y2. So x2 is equal to y2 is equal to b. So the formula we're going to come up with is the same as the slope formula. Is fb minus fa over b minus a. Okay. So I don't want you to look at this and say, okay, I'm freaking out. This is getting to be really complicated. Like, you own this already. You're good at this, right? This is just a slope function, except it's dressed up in slightly fancier clothes. Okay. This is called average rate of change. Okay. That's all that is. Now, we're going to get a little bit fancier here, so just be aware that you already own this. So what we do is we're going to have the same picture. I'm just going to relabel some things. So here's my y. It's my little formula. It's the same, more or less same kind of curve. Okay. So do is we're going to just call this an arbitrary. Just going to call it x. And then down here, okay, I'm going to add something to this x in order to get to my next spot. Right? We're going to say, well, x plus some kind of a change in x is equal to this spot right. So this y value, right, is just x. This is again over here. Come over here. And instead of calling it like 2, okay, we're going to call this f plus delta x. Now, if I go back to my slope form, right, we're going to say this is y2 minus y1 all over b minus a, right? x2 minus x1. Now, we can simplify this a little. So this is f plus delta x, x. Okay. Now, this is what's going to make it a little bit more complicated. Somewhere in the 1970s, 1980s, actually before that, no, but 70s or 80s, publishers decided that delta x, this was too hard. So we're going to call it h instead. Okay. So instead of worrying about delta x's, I don't understand why this decision was made. A chemistry book has delta x's in it, h, but I calculus what makes sense. So x plus h minus f x all over. You can write it either way. If you like the old school, write it this way. You want to conform, you want to make your homework. It's going to happen this way. It doesn't matter. It really doesn't. Whatever makes you happy, write it that way. Okay. So this is our difference quotient. So why is this the difference quotient and this one's the average rate of change? Well, the average rate of change has the connotation that you're working with numbers. And the difference quotient has the connotation that you're working with symbols. Average rate of change tends to be discrete values. So if you're doing finance and you're trying to figure out what's the stock market right from day to day, or does a stock change from day to day, you would say the words average rate of change. If you were working on the stock market, you were checking the price like every second, you would use the term difference quotient. Okay, but they both mean the same thing. So if you ended up not going at school, so generally this has symbols and the h's are very small. This one, the h's are not so small, like 1 day versus 1 second. And generally you're dealing with pure values. So this is like more of a technical formula, and then this is more like a theoretical. Just give you some context, like why are these formulas the same but different names? That's why. So difference quotient. You have 5. Okay. And each of these can have like 1 or 2 extra levels of difference. To explain what I mean by that. But this is for a line. Where did this come from? This came from being able to say what's going on, right? We say what's this, the idea of this slope. So remember, formula we got this from is the slope one. So if I ask you, if I give you a line, I say, hey, I'd like to know what the difference formula is for difference quotient is for like 3x plus 7. Do you have to go through this? No. The answer is 3. Slope. Okay. Quadratic. Your homework has some of these in it. Ax squared plus bx plus c. I'm going to put numbers into the A, C. Okay, don't. This is the thing. It's going to ask us a general question. Now, when it's in here, and you have to. So an example might be 2x squared minus 3x plus 7. Quadratic or not? Rational. So that could be like x minus b, something like that. The a and the b, that's your extra level of difference. So I'm not going to ask you for this, right? Whatever x. We're going to ask you a little bit. Okay? So something like 1 x minus 2. 3 plus 7. I might put a number in here. So it might get something like that. 1 3x minus 2. But generally I restrict myself to something like radical. That's going to be a square root. We'll say ax plus b here. It generally won't be on the outside, the inside. So an example of this might be 3x plus 1 square root. x plus 5. Okay, and the last one is cubic. Okay, so 1, 2, 3, 4, 5, cubic. So that is ax cubed plus bx squared plus cx plus d. And that we would have to figure out the difference quotient for this one. Because of this, it's kind of tedious. So what I would generally do is probably something like x cubed plus 7x. X cubed minus 4x. That would be a good difference quotient problem. More than that, and it's like you're going to be here for this problem. And that's not the point. Let's look at a couple of examples. And the way I'm going to ask you this question, so where do I? This formula? No, not yet. Calculus? Yes, you're done. Pre-calc? Not yet. So the question is going to be like using the difference quotient. Comma plus h minus f x h. Determine difference quotient of square root x plus 5. Okay, that is exact. Again, I'll be typing this out. Okay, you're not going to go with my curve here, but you're going to end up with f of x plus h minus h for this function here. So how do we set this up? So we're going to write this down. Now remember, function notation, right? Whatever you see here, you're going to replace x by what's over here. So this is equal to the square root of x plus h. It's 5. We substituted x plus h in for x. Minus, what's the original function? It's minus 5. It's plus 5, sorry. All divided by h. Okay? And now we have to work this and solve it. None of the answers you're going to get are going to look like things that look like answers. Okay, so the goal is once we cancel this h here, this one, okay, then you're done. Let's go this. Let's go back to draw this h. That's the one you want to cancel. So let's go ahead and get started. We need to get rid of the square roots. How do we get rid of the square roots? So we square both sides. We don't really have it both sides. All we have is really we just have a expression. There's no equality. All right, you're stuck with expression. So there's no both sides. Yeah, I just can't randomly square stuff. Right? I'd say I'd square my bank account, but square stuff that's under. Right, if your value under 1, square it. You have 50 cents in your bank account and I square it, then I'm going to have a quarter, right? I don't want to do that because my bank account's kind of small. So, I don't want to square both sides. I'm losing money. Okay? So what are we going to do? We're going to multiply by 1. So we have square root x plus h plus 5 over square root plus 5 over h times 1. Wait, let me draw a big line because the one I'm going to pick is called the conjugate conjugate of the numerator. Notice the terms are the same except what's different, the plus. Okay, top and bottom. So this is 1. Okay, it's kind of a funky looking one, but it's 1. So what's going to happen? Well, we have the square root of something times the square root of something, right? So this. So we have the square root of something times itself is equal to the first thing, the argument in the square root. So we're going to get x plus h plus 5. So that's my first terms, okay, outers. So that's going to be a plus, and outer terms are going to be plus 5 plus h. One thing you should have learned in intermediate algebra is when in doubt, FOIL. Okay, so I'm multiplying out the outers here. So this is minus x plus 5. It's this piece. So this is my inners. Okay, and then we have our lasts, right? It's because we have a positive times a negative. We have the same thing going on here, right? Square root of a thing times the square root of a thing is the thing. These are parentheses. All over h times square root plus h plus 5 plus square root of 5. We don't have much to multiply out here, but I would beg you, do not multiply out denominators, because even if you do, the next step is figure out where the asymptotes are. So you need the facts at the bottom so you can solve them. So do not go ahead and multiply out. Okay, leave it alone. What's going to happen with this term? That term. What's going to happen? What's going to happen is that these cancel. It's a positive times it's a negative. Same thing. Written in a different order, but that's okay. Right, so what do we have? We have plus 5 h minus x minus 5. Don't forget this negative applies to both of these terms. Divided by plus h plus 5 plus square root plus 5. That is equal to x minus x, right? That's going to be 0. So x minus x, 5 minus 5. What are we left with? We're left with h. There's h here. Divided by. What was our goal? Our goal is to cancel this h here. Okay, that's the goal. And we have x plus h plus 5 plus square root x plus 5. These cancel. What are we left with? Give me one number. All right, very good. So what are we left with? 1 over square root x plus h plus 5 plus square root x plus 5. That's our answer. So I told you they won't make an answer, but that's the answer. Let's go to the next one. How about 1 over 2x minus 5? That seems like a question. Let's find a difference quotient. So that is going to be 1, 2, x plus h plus 5. It's x plus h minus x all over h minus 1 over 2x minus 5 h. First thing I'm going to show you, like how to use up a bunch of paper, and that's to just go through and make this a little bit shorter. So this is 1 over h times over x 2x plus h minus 5 minus 1 over 2x minus 5. So all I did was, instead of having a compound fraction, I just made it one fraction, which is harder. And then we have to go through and do this. I got two fractions here. How do I add two, or subtract two fractions? Get a common. That's what we're going to do. So we're just going to 1 over h. Don't forget about this. Okay, even if you decide I'm just going to keep writing it off to the side, that's fine, but it's not gone. So this is 1, 2 x minus h minus 5 times 2x minus 5, 2x minus 5 minus, this is 1 over 2x minus 5 times 2x plus h minus 5 over 2x plus h plus 5. We're just multiplying by 1 again. That's all we're doing. Do not multiply these out. Don't do it. So here we go. H 2x minus 5 all over. And then here we have 2x plus h minus 5, 2x minus 5 minus, we have 2 plus h minus 5, 2x minus 5, 2x minus h minus 5. Delightful, right? All right, let's clean some stuff up and see what we got. So here's our 1 over h. That's the goal, is to cancel. We have a 2x minus 5 minus. Now, we'll take 2 minus 2, it's 2x. Minus 2h. So minus here, minus, plus 5. Okay? Be very careful when you're distributing. Okay, if you're going to make a mistake, that's where it is. 2 plus h is 5. 2x minus 5. Okay. What is this equal? Oh, there's some stuff that cancels now, isn't there? Isn't that great? So we have 2x minus 2x minus 5 plus 5. Okay. This minus 2 is to the x. We should be drawing that. Let's do that. Okay, so what do we have? We have 1 over h. What do we have on the top here? Minus 2h over 2x plus h minus 5. 2x minus 5. 2's cancel. Oh, those 2 don't cancel. Sorry, it's wrong. Not cancel. That alone. What I meant to say was the h is canceled. That negative 2 is still there. Don't cancel that. So what we have, the h is canceled. So our answer is negative 2 over c is 2 x plus h is 5. 2 x minus 5. That's it. There's your difference quotient. What was the goal? The goal was to cancel this h. Have we done that? Yes. So we're good. Now, this is the one mistake almost everybody makes, and I beg you, don't make this mistake. When you get an answer of 1, notice there's x's and there's h's here, so I would need to give you, right, say, we would have some kind of function like that. No matter which point I pick, right, I have an x and I have an x plus h. I have an x, I have an x plus h. I have an x, I have an x plus h. Notice all of these slopes, right, are going to be at different values. Okay, so it's changing. The slope is changing. You can draw the graph and see it. The slope between any 2 points changes. If I get a constant of 1, that means the slope is always 1. What functions do you know that always has a slope of 1? And it's a class of functions, but it's this class, right? Y equals mx plus b. What's my slope? 1. So it's 1x plus b is equal to y. Okay, that's our first case, right? That's our first case. It's even easier than our first case because the slope is always 1. So if you come up with an answer of 1, okay, and the way you did that was you did this. Cancel those two, got h over h, which was 1. That's what you did. Instead of saying f of x plus h inside here, you put the h on the outside. Exactly what you did. That is a pretty bad mistake. Okay, that tells me geometrically you don't know what's going on. Algebraically, you don't know function notation. So this is a couple of mistakes wrapped up in the 1. So you didn't catch it. Okay, now it's okay. I forgot how to do this, and I kind of got lost in the algebra up here. And it's not going to be a good score, but it's going to be better than this one. So even if you deal with this, like so lost, you know it's not good. But that's like a 3 out of 6 rather than a 1 out of 6. This is like a 1 out of 6. So give me this answer. It's a 1 out of 6. Because you know what? I told you we had 5 things to work with. You think I'm ever going to ask you to do the difference quotient of a line? The homework might. You think I'm ever going to ask you that on the quiz? Not a million years. It's way too easy to come, right? If we were talking intermediate algebra, maybe. Okay, if we had a class before that, Maybe. So if this was your intro to algebra class of high school, I might ask you this question. We're beyond this. So the ones you got to watch out for. In a good mood, it's going to be one of these. If I'm in a standard mood, it's going to be one of these guys. And if I'm, so this is this one for the quadratic, right? I'm happy. I don't want to stress you too much. It's a good final exam question. These guys, right? Yeah, you know, that's your standard. You should expect one of these. Okay, I'll flip a coin. That's what I'm going to decide. Okay, this one, it's tedious. We'll do this one, but you're not going to be in a bad mood. I gave you this one. It's like they're easy, but it's a welcome. Let me show you. So let's try. Let's do x equals. How about we do an x cubed minus 5x? How about plus 2? All right. What is f of x plus h? Well, that is f plus h. X plus h cubed. X plus h plus 2. Okay. We got to work this out. Now, if okay, go check that. Okay, they have a little module on binomial theorem that will let you do this very quick. Okay. If you don't want to do it, that's okay, right? But it will make your life easier and well. Okay, but we don't have it as a bring outcome in this class, so not going to worry about it. They teach binomial theorem. This is taught to 9th graders, 11th graders, 13th graders, that's you, 15th, and 17th. So it can go anywhere from like high school, beginning high school stuff to grad school. If you look for a YouTube video on binomial theorem and they're going on about stuff, proof by induction, and all that, like you're in the wrong spot. Okay, you're in the wrong spot. Go to one of these. So don't feel because it spans a long part of your education. It can, not every curriculum does, but if you got to the spot, it's like step at a time. That's fine. You don't have to. Go find a different video to watch it. Okay. Purple math is very good. They're meant for about this level. So it's a good spot. So let's go ahead and do that. It's plus h, it's plus h, it's plus h. Okay. So what if I just pick two of them? X squared plus 2xh plus h squared times x plus h. And now we got to go through these. So it's not the worst thing in the world, but it is the tedious. Okay. So that's the x times everybody. Now we're going to do the h times it. So h times x squared, that's going to be x squared h. 2xh times h is going to be plus 2xh squared. 2 h's now. Plus h cubed. Cubed plus 3x squared h plus 3xh squared plus h cubed. So people tend to get, you know, if you're going to make a mistake, it's going to be in the air. Be careful. Some high school teachers will make you memorize this thing. If they did, that's great, but not everybody. So when I've got my setup, we've got x cubed plus 3x squared h plus 3xh squared plus h cubed. What's my next formula? This was going to be minus 5. X minus 5h. Don't forget it's minus, right? We start off with minus 5x plus h. So go through and do that. Plus what's my constant? My constant was 2. Minus. What was f of x? X cubed plus minus 5x plus 2. All over h. See, it's just long. Okay. minus 5h plus 2. Distribute, it's x cubed plus 5x minus 2. All over h. Some stuff cancels now, right? So that cancels with that. This cancels with that. 2 cancels with 2. So what do we have? We have 3x squared h plus 3x squared plus h cubed minus 5h all over h. Notice there's an h in each one of these terms. Okay, so this is h. 3x squared is 3xh plus h squared minus 5 over h. We cancel the h's, and we are left with 3x squared plus 3xh plus h squared minus 5. From handwriting notwithstanding. That's the answer to this one. So it's not, again, it's not exactly a problem. I think it's actually easier than a radical, but I've given this problem, a problem like this before to students, and I get everything solved for the answer because they screw up multiplying all of this out. These techniques up here with the radical irrational equations, those are important techniques that you're going to need in other classes. Multiplying out a polynomial a lot. Okay, if you know binomial theorem, it's extremely easy. I didn't learn it until I was a junior, so I didn't learn binomial theorem until like grade 15. Okay? Now I was like, where has this been all of my life? Why did you make me wait to learn this? Right? Because my algebra teacher would think nothing of doing something like this. Okay, I know this was to shut us up for 10 minutes while we work through all of this, but honestly, this is a 2-line problem if you know by. So that's it. We're not going to worry about that yet. Okay. I'm not going to ask you one like this. Like, if you can do x plus 7 to the cubed, you can do it to the 5th, to the 7th. Doesn't matter. It's just time. So I'm not asking you stuff like this. Maybe this one combination with this problem, but yeah, we're not. This is more like. Why? Because we have 6 cubes. Everybody plays Dungeons and Dragons now, right? Just know that you have to figure out like these 3 6-sided dice that 6 cubes. It's your denominator, 6 cubes. It's 216. So every self-respecting parish now 6 cubed is. It's me. All right. So that is average difference quotient. Sorry, no cat today. She's asleep. But that should give you a taste for average rate of change and difference quotient. Stop there. So hopefully that does 1.8 for you. There's still a couple of tricky problems in there. So be careful. But this is the worst of it. So next video.